Hi there! Welcome to the second part of the tutorial how to play a video on Arduino. In this episode we will show you how to hack a popular TFT plus SD module in order to enable high-speed transfers. Let's go for the next hack! This is the display we will use in this project. It is low cost and also has the SD card socket, which is routed to the connector on the right. It also includes the 5 to 3.3 volt linear regulator. Of course, you can use different modules if they have the same specifications. However, there is an issue with this module. The maximum speed we can achieve with the SD card is limited to about 1 MHz because of these resistors. In order to test if the SD card can work at 8 MHz, we used the FATFS library available on Chan's website. Using this library, we wrote a very simple sketch that performs low and high-speed read tests. For this test, we need a decently sized file on the SD card. For instance, you can create a 640 by 480 image and save it as 24-bit bitmap. Be sure to name it test.bmp. This will create a 900 kilobyte file. Then, copy the created file to the SD card. After that, we need to solder a 16-pin header on the module because it is normally not populated. The test circuit is very simple, as we just connect the SD lines to the SPI of the Arduino. It's time to build our test circuit. Even if the SD card works at 3.3 volts, we directly connect the Arduino to the unmodified module because it has the protection resistors. You can see 3 status LEDs. Let's have a look at them. The red LED turns on when the program starts. Then the green LED flashes during reads, indicating the test is ongoing. When the low-speed test completes successfully, the blue LED turns on, indicating that now the high-speed test is being performed. The red LED turns off when the high-speed test completes successfully. However, if for any reason the test fails, the red LED will remain on and the green LED won't flash anymore. As you can see, the unmodified module passes the low-speed test, but it fails at 8 MHz. We already said that the speed limit is due to these 10 kΩ resistors, which are in series to each SD input line. They prevent any damage when the SD card is connected to a 5-volt system, such as our Arduino. However, such resistors form a low-pass filter with the SD and track capacitances, blocking the high-speed signals. To verify this, we created another simple sketch that outputs a variable clock frequency on the SCLK line. We then connected the SCLK line to the oscilloscope, and as you can see, the clock signal is too much degraded above 1 MHz. The solution is to reduce or short out such protection resistors. Now, since we removed the protection resistors, we need a voltage level translator. For instance, we can use resistor dividers as shown in the schematics. Therefore, we modified the circuit according to the new schematics. Let's repeat now the test. As you can see now, high-speed read is possible. Also, using the scope, you can now verify that the clock is within specifications even at 8 MHz. That's all for this episode. Don't miss the next part, in which we will discuss about SPI, USART and speed optimization. All the schematics, programs and breadboard layouts can be found in our website, next-hack.com. Please share, rate, comment and subscribe to this channel. Thanks for watching. What's your next hack?